So hello friends, till now we have seen conceptual part of unit 1, that is design of simple machine elements. Today we are going to start with the part 2 of the unit 1, that is design of actual simple elements. So there are n number of simple elements, but for the syllabus we have to design Cotter joint and knuckle joint. So we will see what is Cotter joint. So Cotter joint is used to connect two coaxial shafts or rods which are subjected to either axial tensile force or axial compressive force. So typical applications are joint between piston rod and the crosshead of the steam engine, the slide spindle and the fork of the valve mechanism, the piston rod and the tail or pump rod, and fourth, foundation bolt. So these are some of the examples of the Cotter joint. Now we'll start with the design of Cotter joint. Before that, we'll see how the Cotter joint looks like in a 3D view or in a picture. So as we see, Cotter joint has three parts. One is spigot, socket and cotter. So we can easily understand spigot goes into socket, and after assembly of spigot and socket, from upper side we can insert the cotter, so that spigot and socket will get joined. So cotter is nothing but element having wedge having taper of 1 is to 24 or 1 is to 32. We can see again 3D simple parts of the assembly: socket end, socket end, cotter and spigot end. So one can easily understand spigot will first of all go into the socket, and socket and spigot will be joined with the help of cotter when they will get assembled. You can see the direction of force here. So this is the direction of force and this is the direction of force. So after assembly the rods, so these we can see, this is the socket end and this upper portion on which the force is acting is rod having particular diameter. So these two are the rods, this one is rod and this one is rod. If we have to see the animation of the failure cotter joint, then on YouTube I have given the link, you can go through the animation of cotter joint. Then we will see different dimensions of the cotter joint. So first of all we will see the front view of the cotter joint, then side view of the cotter joint. Obviously it is on right hand side, so left hand side view, and there will be a top view. Okay, so first element is nothing but rod A. You can see here rod A. Okay, this will be a rod A on which force P is acting. Next is rod B, then cotter, then spigot, then socket, then socket collar, spigot collar. Then cotter and socket has small clearance provided here, so the clearance is provided between the socket and the cotter, and one clearance is also provided between the spigot and the cotter. Here a small clearance C is provided. You can see this clearance is provided in the cotter and the spigot. Okay, so P is tensile force acting on rods in Newton. D is the diameter of each rod. D1 is the outside diameter of socket. D2 is diameter of spigot or inside diameter of the socket. D3 is the diameter of spigot collar. So you can see dimensions here. D3 here. Then where is D1? D1 will be okay. So D1 is diameter here, rod diameter. D is rod diameter. D1 is outside diameter of socket. This will be a socket, outside diameter of socket. D2 is the diameter of spigot or inside diameter of socket. So one can easily understand D2. So here is our D2. So whatever is the inner diameter of socket, that will be the outer diameter of the spigot. So this one is spigot, this one is socket, this will be inside diameter. So obviously these two diameter, outer diameter of the spigot and inside diameter of the socket will be same. D4, diameter of socket collar. You can see this as a socket, okay, and this collar here, this collar is there, so that collar is nothing but socket collar. Then A, distance from end of slot to the end of spigot on rod. So A, so where is your spigot? One can easily understand. Okay, sorry, one can easily understand. This one is, okay, this one is socket. Okay, so one can understand. This is your distance A. So where your spigot ends, okay, where your spigot yes, where your spigot starts, this distance becomes A. Mean width of the cotter. So we know that a cotter goes on reducing, so shape of the cotter goes on reducing because it is having taper. So mean width of the collar I have shown here in the diagram, that is this one is the mean width of cotter. Then C, axial distance from slot to end of socket collar. Next is thickness of cotter, T. So this will become the thickness of cotter. Then T1, thickness of spigot cotter. So T1, you can see here, whatever spigot collar is there, of which thickness is T1. L is the length of cotter. So you can see in the side view, L is the length of cotter. Okay. Now you observe this diagram, you redraw this diagram and try to locate all dimensions which are shown in the right hand side here. So whatever this part I have shown here, so you try to locate here. So front view, top hand side, you draw it somewhere, you observe it and try to understand. Okay, so you can stop the video here, you can actually see the all dimension, you match all these dimension in the diagram and then try to understand. You can pause the video, you can understand it. So what is the free body diagram of the cotter joint? So we know that on the cotter joint we are having, yes, on the cotter joint we are having these three n number of dimensions are provided here. So how is the free body diagram? Okay, so there is first part socket, second part cotter, and third part will be your rod. Okay, so third part will be your spigot. So you can see rod A and socket are the integral part, they are made as a one part, not different parts. Similarly, this rod and spigot is an integral part, these two are not different parts, and when these two are inserted from the slot of these two, they can be drawn. Okay,